Watch this video in Lesson Reach. Pause and ask questions, take a quiz, or get help with assignments. Link below.
Usually when we think about a contract, we picture a stack of papers, dense legal jargon, and a signature on the dotted line. It is very tangible.
Yeah, exactly. It is something you can hold.
Right. But what if the rules of a binding contract were totally invocable, like governing everything from the arguments you have at the dinner table to the smartphone in your pocket?
It is a pretty wild thing to think about.
It really is. So welcome to the deep dive. Today, we are looking at how the invisible contracts of mathematical logic govern our world.
And we have some great material to pull from today.
We do. Since we are pulling this straight from section 2.4 of chapter 2 from Contemporary Mathematics, let us just lean into the academia a bit.
I love that idea.
Yeah. So I will play the role of the inquisitive student trying to poke holes in the theory, and you can act as the logic lecturer for us and for the listener.
I will gladly take on the lecturer role today. Our mission is basically to take these formal rules from the textbook and show you how they practically dictate both human rhetoric and digital technology.
So to set the baseline for you listening, let us look at the standard conditional statement.
Right, so in logic, this is P implies Q. Since you likely already know the basics of an if-then statement, let us focus on the mechanics of why it functions like a strict legal contract.
Okay, yeah, that makes sense.
Section 2.4 uses a classic scenario. A parent tells their child, if you do your homework, then you can play your video games.
Okay, well, let us unpack this. Because if I try to map that onto my own life, it is like me saying, if it rains, I will bring an umbrella.
Exactly, yeah.
So the hypothesis is the rain, the conclusion is the umbrella. If it rains and I bring the umbrella, the contract is satisfied. True implies true.
Spot on.
And then if it rains and I forget it, I broke my own rule. So true implies false is logically false.
That captures the standard conditions perfectly. But the architecture gets far more interesting and honestly counterintuitive when the if condition is not actually met.
Right, and this is where I need to put my student hat on and push back a little.
Go for it. Let us hear it.
The textbook says that if I do not do my homework, meaning the hypothesis is false, but my parent lets me play video games anyway, making the conclusion true, the statement as a whole still evaluates as true.
Yep, that is mathematically right.
Wait, false implies true equals true. That feels completely broken. I mean, how does that make sense?
That is the exact trap most people fall into when analyzing arguments. You really have to evaluate logic based on whether a promise is actively broken.
Okay, I am listening.
Because the homework was not done, the hypothesis was false. And that basically means the contract was never actually entered into.
Oh, I see. Because I did not trigger the part of the statement, the parent is essentially off the hook.
That is the exact underlying mechanism. Since no contract was initiated, well, no contract could possibly be violated.
That makes total sense now.
Right. The parent did not break the terms by letting you play anyway. So, the original statement remains logically valid.
Wow, that shifts how you evaluate an argument completely. I mean, a statement is not a lie just because the outcome happened through a completely different trigger.
Exactly. But obviously, sometimes we do need stricter rules than that.
Right, of course.
And that brings us to the biconditional statement. This is the if and only if scenario. It is a strict two-way contract.
Okay, so how does that work compared to the other one?
Well, a biconditional is only true when both the hypothesis and conclusion perfectly match. So either they are both true or they are both false.
Oh, I think I get it.
Think of it like airline security. You can board the flight if and only if you have a valid ticket.
No ticket, no flight, have a ticket, you board.
Exactly. Both sides have to align perfectly for it to be true.
So how does this abstract math jump off the page? Because later in section 2.4, the focus shifts to computer programming. And I really want to connect those dots for the listener.
Yeah, that is a huge part of why this matters today.
Like, do these strict two-way contracts actually dictate how software runs?
The connection is completely literal. Every single programming language relies on these if-then-else decision statements to function.
Really? Every single one?
Oh yeah, all of them. A program evaluates a condition, and if the condition is true, it executes one line of code. If false, it executes another.
That is so cool. The textbook highlights Ada Lovelace here, which I think is a perfect historical anchor.
Oh, absolutely. She was brilliant.
Right. Back in 1843, she wrote an algorithm for Charles Babbage's analytical engine to compute Bernoulli numbers.
way ahead of her time, honestly.
Yeah, so before computers even existed in the modern sense, she was proving that these exact truth tables are the foundation of computing.
She essentially proved that human logic could be translated directly into machine action.
Wow, that is massive.
Yeah, she saw that a machine could act on pure logic, and not just calculate raw numbers.
So what does this all mean for you listening right now? I mean, mastering these truth tables gives you a mental framework to evaluate arguments. It helps you see whether the arguments you hear every day are logically valid or just completely broken, based on the invisible contracts people set up in their speech.
It really allows you to see the underlying architecture of the world around you, from a political debate all the way to the apps on your phone.
For sure. But it does leave me with one final thought for you to mull over.
Oh, what is that?
Well, if all of our modern software is built on these incredibly strict, binary, true or false logic gates, is it ever possible to program a machine to truly understand the subjective, messy gray areas of human promises?